question is, can we agree to disagree on climate justice, or how to operationalize divergent equity principles to mitigate global warming? So first, a little bit of political context to introduce the research question. So here we can see first the timeline of the establishment by the international community of a body called the IPCC, and the Intergovernmental Panel on Climate Change, that summarizes the research and compiles the research on climate change adaptation, mitigation of emissions, and the climate impacts. And so this body produces assessment reports every 5 to 6 years to inform the international community on the dangers of climate change, but also on how to mitigate it. So the international community has set the UNFCCC, which is the United Nations Framework Conventions on Climate Change, in 1992, with the goal to stabilize global greenhouse gases. Following that, there has been first a protocol with Kyoto for some specific actors to limit emissions, but really there has been a clear definition of on the stabilization of greenhouse gases with the Copenhagen Accord and the Cancun Agreement to limit global warming to 2 degrees. And finally, with the Paris Agreement, there has been an increased ambition to limit global warming to well below 2 degrees and pursue efforts to limiting global warming to 1.5 degrees, and also a goal to reach net zero emissions in the second half of the century. So while we have a progress in global ambition, we still have cumulative emissions increasing in the atmosphere, and even the annual rate of emissions increasing. So we have a gap between global ambition and the accumulation, the aggregation of national ambitions. So that's one of the points to be negotiated, to still be negotiated, and we'll here focus on the questions around mitigating greenhouse gas emissions. So for the future negotiations, the IPCC should produce a report on 1.5 degrees, so both climate impacts at 1.5 degrees and 2 degrees, and the mitigations options to reach that goal. And the UNFCCC has, with the Paris Agreement, agreed to have a ratcheting up process where it takes stock of the progress to achieve the global goals set out in the Paris Agreement. First in 2018, and then with a global stock take every 5 years, where countries have to bring new commitments to reduce emissions with increased ambition. So the world needs to reach net zero emissions in the second half of the century, and that implies that there's only a limited amount of emissions that can be emitted. And the disagreement, the reasons why there's a mismatch between global ambition and aggregation of national pledges, is that countries do not agree on the burden sharing associated with reducing emissions. Because emissions originate from energy system, transport, and agriculture, and many sectors that are critical for economical activities and development. And there are different positions of equity that different countries adopt or support to share the efforts needed to meet the global goals. So what are the current national positions of equity? There has been some workshops under the UN. Some countries also produce some national documents explaining their positions. If we have a quick look, we can see, for instance, here that the like-minded developing countries, which is a group of developing countries that includes China and account for a big amount of emissions, 42% in 2010, supporting notions of historical responsibility. Europe has supported in some documents historical responsibility. That means that large historical emitter should take on most of the mitigation burden in the future, and so should emit less in the future. Notions of capability, meaning that countries with the highest GDP, financial means, should take on most of the mitigation burden. The least developed countries supported a right to develop. So that means having sufficient emission space, being able to emit sufficient emissions to pursue their development. So under the UN, the UNFCCC, and also under the Paris Agreement, there is a common equity principles that was agreed by all countries. That is the common but differentiated responsibility and respective capacities. So this equity principle applies to all, but different countries support different interpretations of it, and sometimes have different ways of seeing its implementation. So how can we operationalize divergent equity principles? That's the research question we're tackling here. So let's look first at the literature. There has been a rich body of literature suggesting different burden sharing emissions to share out the remaining emissions to stay below 2 degrees, mostly, since the 1.5 degree goal is only newly adopted as of 2015. And so since the 90s, many different burden sharing schemes have been put forward, determining how much each country should reduce emissions. In the latest IPCC report, there was a study that was reproduced in the report that categorized over 40 different studies looking at burden sharing schemes into 5 equity categories. So these 5 equity categories are capability that I spelled out before, equality, mostly aiming to achieve equal per capita emissions, responsibility, capability, and need, mixing these different notions, responsibility being interpreted as historical responsibility. Equal cumulative per capita scheme that is taking into account only historical responsibility, so that the inequalities in historical emissions are compensated in the future. So, like I said, high historical emitters have lower allocations, emissions allocations in the future. And stage approaches, which is countries adopting different schemes at different points in time. So this is what the graph that the IPCC has provided. As you can see, it's only looking at the regional level. So OECD, EIT being economies in transition, so Eastern countries, Asia, Middle East, Africa, and Latin America. So this graph indicates emission reduction level for 2030 compared to 2010, so percentage reduction across these 5 regions and for each of the 5 equity categories. So the spread you can see here is sort of depends on the modeling framework adopted by the different studies that might not necessarily be consistent in its parameterizations. For example, when do they start accounting for historical emissions? What kind of data do they use? And so the greater the number of studies, the greater the spread. Not always, but that's sort of direct consequences across the mitigation target that this region can adopt. So this is for 2 degrees, looks at a consistency with the 2 degree goal. There's nothing on 1.5 degree. And this study also did not derive target at the national level. So that's sort of the summary of the literature. Now, if we look at how to combine different equity categories, that may seem paradoxical because equity approaches or principles of distributive justice are meant to be applicable to all individuals in the world and not combined together or applied differently. But there has been some suggestion in the literature. So this is the most commonly used website to track, to keep track of the ambition of different countries. So it leans directly on the study I've showed before, and to assess the emission of a country's climate pledge, emission reduction pledge, it compares it to the whole range of equity allocations that I showed before. And depending on where this the climate pledge sits on that range, it would give sort of a sufficient grade or role model or medium. So if it sits in the least ambitious end of that range, it will be only medium. If it sits even above that range, it will be inadequate, and so on. So different equity approaches are treated blindly and sort of count equally. There has been other approaches. There was a study in 2014 looking at blending different equity approaches using weighting coefficients. So an example is if we use equal coefficients, it comes down to doing an average. So we calculate the allocations for a country according to different visions of equity and average it, for instance. But that implies to attribute to a country an equity principle that they might not directly support. There was another study that looked at what if the EU adopted a 40 % reduction target, what are the consequences for other countries and how can they adopt their own mitigation targets? So that's sort of a differentiated approach where one country picks its own approach, but it was just done for the EU. And finally, there was a study by Manta Meinshausen and myself in 2015 looking at how can a leading country set the ambition for other countries so that if all other countries follow the ambition of that leading country according to their own vision of fairness, it would add up to the 2-degree goal. So let's look at the work done as part of this thesis. So the first thing that I needed to do was to develop an emissions allocation framework, a modeling framework that could allocate emissions across country consistently using similar parameterization, similar global goals so that we could compare the effect of equity allocations, but also blend them in the future in a consistent way. So the choice was to try to model approaches that are consistent with the 5 IPCC equity categories. So the capability one, equal per capita, that converges to equal per capita allocations in 2040. For capability, the modeling choice here was to allocate a share of global emissions to a country that is inversely proportional to their GDP per capita. So the richer the nation, the smaller share of the global emissions. The greenhouse developments right is an approach suggested by an NGO that mixes notions of historical responsibility and capabilities and allocates an effort between a baseline scenario, a business as usual scenario, and the target scenario that needs to be achieved. It relies on business as usual projections for different countries. So these are contentious baselines that countries would need to agree on, so it's a difficult implementation. The next approach, you call cumulative per capita, ensures that all countries have an equal ratio of emissions over a given period over population over that same period. And finally, the constant emission ratio was an approach that was also included in the stage approaching that's a grandfathering approach that preserves the emissions ratio of countries as of today. So it preserves, through decarbonization, the current unfairness of repartition of emissions across countries. So it also serves as a baseline of equity to see how other approaches can depart from that trajectory. To model these approaches, usually burden sharing approaches in the literature, not always, but usually are applied to carbon budgets. So carbon budget is the amount of CO2 that can still be emitted to stay below 2 degrees. It's simpler, but it has some disadvantages. For instance, countries are then allocated budgets that they can use the way they want, and we could imagine that a country could use a big share of that budget in the near future, pledging to drastically reduce emissions later on. But it's hard to keep track of the progress of all countries, and we might not see emissions decreasing at the global scale depending on how countries use that budget. Also, budgets only work for CO2, but not for short-lived greenhouse gases, such as methane and other Kyoto greenhouse gases that are still important factors of global warming. So instead, the modeling choice here was to allocate the emissions of global emission trajectories. So some other bodies of science are modeling global emission trajectories that depend on the cost of technology that is foreseen for the future, different policies for implementation. Here we have an example with the red line that is across all the graphs. These are global emissions. So you can see them ramping up to today. And this pathway is called RCP 2.6. It's a representative case of an emission scenarios leading to preserving a likely chance of 66% chance or more to stay below 2 degrees. So you can see that in the future, unsurprisingly, emissions are going down to 0 and below. So the question that we're trying to answer with this modeling framework is how do we share the emissions, the future emissions of that pathway across countries? So you can see the historical part on the left-hand side, and then that's where the modeling framework is applied to determine emissions for the future. So capability, here we can see the US going to near zero emissions in 2040, equal per capita emissions with a slightly bigger share. The US can still have a little bit, greenhouse developments, right? equal cumulative per capita, implying negative emissions quite early on for lots of developed countries, and the grandfathering approach, where all countries reduce emissions at the same rate. So if we look at the current inequities along those indicators, we can see here, for instance, the population in 2014 and the emissions in 2014. Now, if we look on per capita basis, we can see per capita, let's look first at per capita emissions in 2014. We can see that, unsurprisingly, Western developed countries, but also Eastern countries have high per capita emissions. But it's quite gradual across countries. So there are countries sitting pretty much at the entire, all the way on the spectrum. We got here all the values, all the legends at 5 times the world average to look at the contrast. We can look at the per capita cumulative emissions since 1950 and 1990. So we can see that here, most of the cumulative emissions that occurred since those dates are located in Western countries and also Eastern countries, but less so in the South. Here, emissions have been discounted incrementally in the past at a rate of 1.5% to discount for technological improvement. And if we look at per capita GDP here, we can see a much clearer contrast with really not a whole continuous set of countries along the scale, but really developed countries being much richer than any other country. So we can expect the contrast in current inequality on GDP per capita to be reflected in the future allocations that take into account per capita GDP for the future. So once we had this framework, so we wanted to publish it, and with some co-authors from Germany and the University of Melbourne, we decided to apply it to a real-world case and apply it to the G7 ELMAO agreement that was in summer 2015 that set some guidance on how to achieve net zero, how to achieve the 2-degree goal through the adoption of specific mitigation targets. So the G7 agreement set out a target to limit emissions in the higher end of the IPCC, recommended IPCC range for 2050, which was 40 to 70%. So here we interpreted as a 60 to 70% reduction in 2050. And the ELMAO agreement also specified that the world should reach net zero CO2 emissions by the end of the century. So we selected the trajectories from the IPCC database that are consistent with those goals. So there's about 800 scenarios, some of which limiting to 2 degrees, some of which leading to higher warming. So really we selected the 8 that matched this two criteria, and we added the RCP 2.6 that I showed before as its representative case of emission reduction leading to 2 degrees. So here already we can see the trajectories that the world can follow to meet those goals. And we can see here the aggregation of the current climate pledges, the nationally determined contributions. And so we can see there's clearly a mismatch, and that the aggregation of those climate pledges are insufficient to put us on a least cost trajectory to limit global warming to 2 degrees. So that's one of the graphs we can derive from there. That's similar to the graph from the IPCC that you've seen before. It shows emissions reduction at the regional level in 2030 compared to 2010. It enables comparison with the IPCC results. Overall, we don't find big differences. Our modeling of the capability approach is more drastic to developed countries, but our modeling of the equal cumulative per capita is less drastic for slightly less stringent for developed countries. But overall, it's quite consistent. And the spread here doesn't represent the spread over the literature anymore, but represents the spread over the selected global scenarios. Now that we have this framework, what we can do is really go at the national level. So we can have for all countries, so all countries we have data for, which are over 170 countries, we get emissions trajectories all the way until 2100 according to each of the 5 equity allocations. So here, each of the 5 colors. And we can compare those with the current pledges of the different countries. So here we can see, for instance, for the G7 countries, that their current 2030 targets are only more ambitious than a grandfathering approach. So they do not align with any other vision of equity. If we look at the BRICS countries, we can see that depending on their assessment, because the assessment of some pledges are more difficult and rely on projections on GDP or energy use, India or Brazil can align, their pledges can align with 2 or more visions of equity. But the NDCs, so the climate pledges of China and Russia, are unambitious according to any of the equity scales shown here as they are set out currently. So the takeaway message from here is that G7 countries are not taking the lead despite their commitment as developed countries to take the lead in reducing emissions under the UNFCCC, but also spelled out in the G7 agreement. So later on, after this ELMAO agreement, just 6 months later, there was the adoption of the Paris Agreement that set new goals. And so we decided to apply this emissions framework, again, with people from Germany, Austria, and the University of Melbourne, and to really set out emission trajectory consistent with the Paris Agreement. So the new goals of the Paris Agreement imply well below 2 degrees and not just 2 degree goal to pursue efforts to limit global warming to 1.5 degrees and net zero emissions by the end of the century. So not just CO2 emissions, but greenhouse gases emissions. So it's more stringent than the net zero CO2 goal of the ELMAO agreement. So then again, we selected scenarios from the IPCC database that matched those goals. Here we will only keep the blue shading, which reflects scenarios that do meet those conditions, but also peak emissions before 2030, as the Paris decision called for peaking of emissions as soon as possible, and also these scenarios has fairly high sulfur emissions. Now, we needed to find scenarios consistent with a 1.5 degree goal, and in even taking a median, so 50% chance of not just keeping global warming below 1.5 degrees, but only to return to 1.5 of global warming in 2100. There were only 2 scenarios that met those criteria in the IPCC R5 database. So we had to take scenarios from also an additional study that was published in 2015. And so we could identify a set of 39 scenarios. So here you can see the ranges for 1.5 degree and for 2 degree. If we look at the average of those scenario sets, we can see that the average of the 2 degree scenarios sits at nearly 40 gigatons of CO2, which aligns with the recommendation of the Paris Agreement of the Paris decision to limit global emissions to 40 gigatons in 2030. But they did not specify a goal consistent with the 1.5 degree goal, and left that to be determined by the IPCC in its special report on 1.5 degree. Here we identify the average for the 1.5 degree trajectories to be sitting at 32.6 gigatons of CO2. And again, you can see the assessment of NDCs of the current climate pledges of countries being off track and being unambitious compared to these trajectories. So let's now look back at this graph. You have seen it before. We can now compare, again, the 2030 emissions reductions for the 5 different world regions and compare them with their aggregated NDCs, so climate pledges. The only region that is performing well across a wide set of indicators is Middle East and Africa. It performs well across all visions of equity for 2 degrees, except for the grandfathering approach. What we can now do is also compare with allocations in line with 1.5 degrees. And so that's new information that allows us to compare the additional efforts towards achieving the 1.5 degree goal. We can also look at it at the national level. So we can produce the graphs that you've seen before. But let's here just specifically look at the difference between the 1.5 degree goal and 2 degree goal. So here, for instance, if we take the G8 and China as a group and look at the emissions reduction, they should have achieving the 2 degree goals. We should see that on average across the different visions of equity, which is it's convenient to average over different visions of equity to see the influence of the global goal. We can see that they should reduce emissions by about 40%. But to meet the 1.5 degree goal on that axis, they should reduce emissions by 60%. So that's a difference of 21 percentage points, and that represents the additional efforts that this country group should produce to meet the 1.5 degree goal compared to the 2 degree goal. So that's the difference, that's the distance to the diagonal. Now, if we show all countries, we can see that most developed countries sit here with a difference of about 20 points, while developing countries have a greater distance to the diagonal, meaning that the additional effort they should produce to meet the 1.5 degree goal compared to the 2 degree goal is greater. So, for instance, Philippines having 55 percentage points difference between those two goals. Now, it should be remembered that any country sitting in that top right quadrant can still have higher emissions in 2030 compared to 2010. So they can still increase emissions, but not as much. We can also look at other indicators. So for instance, the average year for peaking emissions, again, averaged over the 5 visions of equity, equity concepts. Here you can see most developed countries in China sitting here, so peaking emissions as soon as possible in both cases. But for developing countries, they can peak emissions in the future and have an about 10-year difference. So should peak emissions 10 years sooner when aiming at 1.5 degrees compared to 2 degrees. We can look not only at when they should peak, but also at what levels. And we find that they should peak at levels 20 to 40% lower for 1.5 degrees compared to 2 degrees. And we can also look at when on average countries should reach net zero emissions. So again, on average across the 5 different visions of equity, we can see that developed countries should reach net zero emissions soon before 2070 for 2 degrees and before 2060 for 1.5 degree, so about a 10-year difference. And that difference is only about 5 years for the least developed countries at the end of the century. Another question we can answer with results produced here is who can close the mitigation gap between the current commitments, the climate pledges. Here we're taking the conditional climate pledges, which include the most ambitious assessment of the current pledges. I told you there's sometimes some uncertainty, but also taking the conditional pledges, which means that the effort that some countries are willing to do should they receive financial support. So that adds up to about 49 gigatons of CO2 here, and the level to reach 2 degrees of warming is at 40 gigatons of CO2. So here we can see that if China, for instance, follows any vision of equity, it would reduce that mitigation gap. It can potentially close it by simply following a capability approach. The average of those 5 approaches sits here, so it's not closing the gap entirely. We can see the influence of other countries on that mitigation gap. Most developed countries would reduce the mitigation gap by doing what is fair, which is consistent with the fact that their pledge is currently not deemed fair by many of the equity approaches modeled here. And if we look at country groups, we can see that the G8 and China altogether could close the mitigation gap with the conditional indices by adopting the average of the 5 equity approaches. If we look at the mitigation gap for 1.5 degree, we can see that this mitigation gap is much greater. It's about 20 gigatons, while it was about 9 gigatons here. And that now the G8 and China would not close that mitigation gap by adopting any of the 5 equity approach, and that the rest of the world should also increase their ambition compared to their current conditional NDC. So we made all this these results available online, publicly available on a website called parisequitycheck.org. So all the national trajectories are available for over 170 countries for both 2 degrees and 1.5 degrees across the 5 different equity approaches. On the first page of the map, there is sort of an equity choice made here to give a darker shading or more stars for each of the equity approaches that a country's commitment meets. So again, this is sort of a blind judgment. It doesn't matter which equity principle a pledge meets, it gets 1 more star. We'll get back to it later, but we also chose to provide different equity approaches individually so that it's possible to compare how countries are performing on different sets of equity compared to the visions of the equity that they supported. So using this data, we've produced a report looking at G20 specifically, G20 countries specifically, and checking if they are doing what they preach. So this is, again, 2030 emissions reduction for 2 degree and 1.5 degree across the different equity approaches, compared with the current indices, the current climate pledges of these countries. And if we now look into their climate pledge, they had to justify, to explain how their commitment is fair and ambitious. So here, if we just look at which countries declared their NDC to be fair and ambitious, we can see that not even all of them declared them to be fair and ambitious. Only some of them put forward some clear equity principles to justify how they determine their contributions. Many others used other justifications for to back up the equity of their pledge, but without referring to principles of distributive justice. So here it's interesting to see, for instance, that the USA declared to be fair and ambitious, and actually the pledge starts by the American pledge is fair and ambitious, period. And they don't bring any concept of equity to back it up. We can see that some countries like Brazil bring notions of equality, of historical responsibility, of capability. And if we check their NDC, here, actually it does align with the range of all visions of equity except for the capability. So it did support a vision of capability, but overall it performs pretty well compared to what it preaches. Turkey, for instance, supported notions of historical responsibility. And this is the least stringent vision of equity for Turkey, but the NDC doesn't even match that, that range, and it's far above it. So using this data and crossing it with their declaration on equity, and potentially even after those pledges were made, which were before the Paris Agreement, we can sort of, we can see which conditions, which countries are the most vocal on equity, which countries are the most likely to lead the ratcheting up process under the Paris Agreement, and who has room for progress to achieve an equitable contribution. So finally, I'd like to take you to the last bit of the study that's really looking at how to combine different equity approaches. And we'll try to submit this study soon. So this map shows which equity approach is the most favorable to each country. And by most favorable, we mean provides the most cumulative emissions between 2010 and 2100. Unsurprisingly, for developed countries, you can see that a grandfathering approach is the approach that favors them the most, but also for China or Argentina, non-developed countries. And we can see that, for instance, for least developed countries, it's most favorably a capability approach or the greenhouse development right approach that would provide them with the most cumulative emissions. So currently we're in a situation, and coordinated situation, where each country pledges according to their own interpretation of the equity principle. So they can determine their contribution according to their own visions of justice. So let's look at the case, what if each country is to apply the most favorable vision of equity and to adopt a share of the global trajectories to 2 degrees according to the vision of equity that favors them. So to put it as a scheme with two countries, A and B, let's look at two different ways of sharing the emission scenarios to 2 degrees. We can see that country A has a bigger share on equity approach 1, and country B has a bigger share on equity approach 2. So if we give that share to country A and that share to country B, we get an overshoot. This is the 2 degree scenarios that was initially shared, but because countries do not agree, there's a bottom-up overshoot because of that uncoordinated situation. So we aim at 2 degrees in fair ways, according to each country, but we overshoot and get to 2.5 degrees. The question we tried to tackle here in this paper was, is there a lower scenario, aspirational scenario, that we could share across countries, so that if each country takes their most favorable equity approach, they apply it to that aspirational trajectory, and then the overshoot happens to match the 2-degree scenario. So that's what we determined numerically. So here you can see country A follows equity approach 1, that gives it a bigger share. Country B follows equity approach 2. And then they add up, overshoot that initial scenario, aspirational scenario that they initially shared. And the bottom up, so this allocation happens to match the 2-degree scenario. So that's a bit of a hybrid approach that follows a bottom-up situation or a non-coordinated situation where each country picks its favored equity approach, but it has a top-down element of applying the commonly agreed goal of 2 degrees. So if we do the math with all countries and apply using all the 5 different equity approaches, we can see here the initial 2-degree scenario and 1.5-degree scenario. And we can see the overshoot the overshoot of the 2-degree trajectory resulting in a likely chance to stay only below 2.5 degrees of global warming, and the median chance of the median scenarios towards 1.5 degree gets an overshoot that gives a median, so 50% chance of staying below 2.1 degrees of global warming. And here are the 2 aspirational trajectories that allow, that enable a bottom-up sharing that matches those 2 trajectories. What's interesting here is that the current NDCs, the current aggregation of climate pledges, is in line with those trajectories. So it happens to match the aggregation of current NDCs happen to match a world where each country applies its favorable approach. So where each country does what is fair, but in self-differentiated manner. So now that we derived this hybrid allocation of the 2-degree scenarios that enables each country to follow different equity approaches, we decided to apply it to a whole range of scenarios, going from very stringent to 1.2 degrees of global warming, all the way to the least stringent ones to 5.1 degrees of global warming. So we applied it to a range of 121 scenarios. And to determine sort of a scale for equitable contributions across countries using their own vision of equity. To do so, we chose to remove the grandfathering approach that is not considered fair by philosophers and also not explicitly supported by any party, only taking some implicit consideration linked with a grandfathering approach for some of them. And we also removed the GDR approach, which is the approach that I told you is leaning on business as usual emission projections that are very hard to agree upon. And we're left with the 3 equality, capability, and historical responsibility that are more or less orthogonal and that represent the CBDRC principle, so the equity principle of the Convention of Common but Differentiated Responsibility and Respective Capability. So if we apply that new hybrid approach, giving to each country the most favorable share, counting on using as the most favorable definition now 2030 emissions level, we get an allocation for each country under each of the 121 global scenarios of global warming. And so we get a relationship between ambition in 2030 at the national level in terms of percentage of reduction and the global warming implied by the scenarios that the hybrid allocation is applied to. So here, for instance, if we look at Indonesia, we can see the 121 orange dots showing the correlation between the association between their 2030 emissions reduction and the global warming. If we do a second-degree regression, what polynomial fit, we can see here a tendency across those dots. And if we intercept this curve with the current climate pledge of Indonesia, sitting roughly at plus 50% for 2030, we can see that this pledge corresponds to this hybrid allocation of the global scenarios leading to 2.5 degrees of global warming. So we can assess the ambition of different climate pledges on a temperature scale. And we can see that India and Indonesia are relatively ambitious, that the EU and some developed countries are a bit less ambitious. US's current pledge sits at 4 degrees, but would go beyond 5.1 degree of warming should it abandon the Clean Power Plan. We can see that China, Russia, and Canada sitting outside that scale, also less ambitious than the 5.1 degree of warming. And so we can work out doing that for all countries. Oh, sorry, first we have some high uncertainty. So uncertainty coming from the assessment of countries' NDC, depending on their policy projections sometimes. But also across the different set of scenarios that we use to model this relationship. So different global scenarios have different strategy. They can reduce emissions sooner or later. So there is an uncertainty range here. If we do that for all countries, we can get a global temperature map. And so assessing the ambition of all countries across this one scale that enables each country to apply its own vision of equity. So a normative scale for all countries. We can see that these developed countries are the ones performing the best along that scale, with shares of emissions consistent with the allocation of scenarios leading to below 2 degrees of warming, and developed countries being the least ambitious. So discussion and conclusion. So like I said, there are numerical limitations, both coming from the data we use and our modeling. There is the, I didn't talk about the equity of the temperature goal. So is it fair to aim at 2 degrees, 1.5 degrees of warming? Some countries might still be threatened at 1.5 degrees of warming. Only discussed absolute visions of equity that share mitigation effort in order to maximize global good, but some countries might only be looking at competing advantage over other countries, so that was not directly tackled. And finally, we didn't link the question of mitigation with questions regarding adaptation or loss and damage. Also could be linked with the equity of the temperature goal. So what does this work bring? So I and some co-authors derived some new results that didn't exist in the literature yet. So national emission trajectories that are consistent with each of the 5 equity approaches, equity categories of the IPCC, and modeled consistently across these 5 categories. Trajectories consistent with the Paris Agreement goals of 2 degrees and 1.5 degrees. And emission trajectories that add up to cost-optimal global trajectories. And finally, we suggested a novel method that reconciles the divergence of equity in terms of equity by countries with the global temperature goals. So the relevance, first with the multi-equity, cross-equity assessment, now negotiators can assess the ambition of their own climate pledge according to their own vision of equity, or potentially the vision of equity of other countries, but also can assess the ambition of other countries according to different sets of equity. And we also suggested a normative approach that doesn't assume an agreement on equity. So can we agree to disagree? Yes, but there is numerically a cost to that, which is in the case of 2 degrees, if we want to achieve 2 degrees, we should aim at 1.4 degree, and so the cost of disagreement is this 0.6 degree difference. And finally, there's a relevance for legal climate cases, as some of us are working on. So there was a legal case in the Netherlands where a group of citizens sued the Dutch government for not doing enough on climate change, and they won. And the court ruled that the Netherlands, the Dutch government, should at least adopt a mitigation target in line with the least ambitious end of the IPCC recommendation as what is a fair mitigation for developed country. So the court ruled that the Dutch government should do what is fair, but could not judge of what is fair. And so it only ruled the least ambitious end of that range. By following the hybrid allocation that we suggested before, each country is adopting the least stringent equity approach. So a climate case like the one in the Netherlands could, for instance, adopt a recommendation made by the hybrid approach and yet be consistent with a 2 degree or 1.5 degree warming, should it be replicated in different countries. Thank you.
So thank you for a very clear presentation of a wealth of material. Any questions? Roger's got his hand up first.
Thanks, John. Absolutely terrific. Some of those plots have got so much information, and it's really quite hard to absorb it all. What's the role of international trading of carbon credits in this. And for example, you see the US with their capacity trajectory going very negative, lots of negative emissions. Presumably it would be cheaper for them to have less negative emissions and pay another country to reduce their emissions.
Yeah.
More. Well, presumably, I'm not sure if that is the case.
Yeah, so that's actually a point I forgot to touch on. That's one of the advantages of sharing global least cost emission trajectories as opposed to sharing carbon budgets, is that each country, for instance, can meet any of their equitable trajectory through a combination of domestic mitigation, but also potentially the purchase of emissions rights allocated to other countries. And the price of that emissions trading would be set by the global, by the technologies available at the global scale in order to implement the least cost trajectories. And that's actually a follow-up study that could be interesting, looking at what is economically optimal to do domestically and look at the difference with the equity allocation for each of this country, the difference between the two being the amount of emissions right that should be purchased to another country at the price determined by the marginal abatement cost curves of emission mitigation.
Is someone trying to do those estimates of what the economic cost is for different?
That sounds like 2 more PhDs.
Yeah, exactly.
Actually, it's quite straightforward from now. What is missing though? What is missing though is not what I've been working on, is having least cost, the determination of what is cost optimal to do at the domestic level. For now, the modeling of these global emission trajectories look at the implementation of policies and technologies at the regional level only. So we could easily look at a graph at the regional level and look at actually the data already existed in the IPCC figure that I showed in the beginning, and look at the difference between a cost optimal allocation, blind of equity, and equitable allocation. And then we could get an idea of the amount of transfer linked with emissions trading that could occur between countries. And so we could have, for instance, Middle East and Africa selling a lot of emissions right that could also fund their transition. But yeah, to answer your question, I think there are some people looking at that currently at the regional level, at least.
Other questions? Ross?
To have international trade in entitlements to emit, then you do have to have an agreed basis for allocating entitlements to begin with. And so we've got to make your analysis operational, and yet there's almost no discussion internationally of the principles that should be applied. I had hoped that the 5-yearly reviews of the national commitments would be a vehicle for this, but especially with the United States not taking that seriously, it's hard to see that mechanism having real dynamism. How do you suggest we get some real international discussion of the equity principles going?
So that's not directly my area of expertise. I know that the Paris Agreement encourages the implementation of a global emissions trading scheme. There has been some literature saying that having a global emission trading scheme would be difficult and potentially counterproductive, as to follow where is the mitigation actually happening? Is it not double counted and across different types of economy? Could be difficult. There are already alliances of different either countries or states within countries, so what's called non-state actors, and sometimes even across countries, having there's a discussion of different an alliance between Australian states and states in the US or Canada. So there can be also subnational alliances, subnational yet international alliances, and I think there could be the emergence of an emission trading market also through, not directly through the UNFCCC or international negotiations, but at the subnational level, and with more countries joining in as countries are showing progress. And there's the European one as well.
Questions?
Thanks, Jan. So my question is about with your last approach, that hybrid bottom-up approach, where each country is adopting what would be the best equity approach for that country, which gives them the most or the most lenient target. Doesn't that change over time? Like, wouldn't that maybe change in 10 years' time? It might be a different equity approach that would suit that country. And is that incorporated into the model?
So there's two things. So yes, it could change over time, but not in the way. So here we first attributed to each country what provides them the greatest cumulative emissions over the century. So that doesn't change over time because it's already an integration of that spectrum. And then later on, to determine the temperature relationship, we specifically looked at what would give each country the greatest 2030 emissions. And so that choice was to put that in perspective over the current nationally determined contributions for 2030. Sorry. And there's another thing, which is different countries might have different favorite approaches or most lenient approaches for 1.5 degrees or for 5 degrees. And that was taken in account. So at each iteration and for each scenario, the most favorable approach was attributed. So yeah, it might be a different approach for Indonesia here and there.
We've probably got time for one more question.
From your analysis, which country in the G7 is the leader? So which country could be the kind of hero which takes the really ambitious steps and sets the path for the rest of the world to follow?
Let's go back. None really. So there's quite some consistency. So if we look at the scenarios consistent with the G7 agreement, it could be interesting to look at the scenarios that are consistent with both the G7 agreement and the Paris Agreement. So that would be the two scenarios here falling at the bottom of the range because they have net zero emissions. But looking at just these, we can see that the NDCs here plotted in 2030 all meet the same grandfathering approach and fall short of any other. If we look at the long-term pledges, you can see that the US are not doing better. There's a conditional pledge by the European Union to reduce emissions by 95% in 2050 should global actions, global emission increase. And this one would perform better in terms of equal per capita and almost fall into the capability approach.
So Malta's waving hands at me and there's... yeah.
Well, just very quickly, I actually wanted to make a quick comment on a few of the first questions, which is that international cooperation can be achieved in other ways than emissions trading, and that's really the focus of discussions in terms of how countries would support mitigation in other countries, because their burden would be too great to do in their own country. There's many forms of international cooperation that wouldn't require the allocation of permits and the sort of baselines that would require. So I think that's a lot of the discussion at the international level. And then my question, sort of building a little bit on what Ross said around the global stocktake, is do you see this sort of approach feeding into, I mean, at the moment, so the global stocktake is supposed to be on the basis of equity. So it's something that is really on the table for countries to discuss. And do you see research or analysis like this helping to inform those discussions? Like at the moment, countries take very diverging positions on equity. Is this something that could help them come to some kind of central agreed equity approach, or does it highlight the divergences, or what would be the input?
Yeah, so I think it can help informing first across, for instance. So sometimes equity can be used as an excuse for disregarding or putting aside a discussion on the ambition, saying, "Oh, we do not see effort sharing in the same way as you." So here, by having a consistent modeling across the different visions of equity, at least even without an agreement on what is equitable, we can at least measure the ambition of a country against its own statements of fairness. So that would help ramping up ambition. Probably not to levels consistent with the 2 degree, because countries tend to support visions of equity that favors them. And this is why we suggested the last scale, which is an agreement to disagree, which is combining different visions of equity, which again can sound paradoxical because equities are meant to be applicable to all, but each country applies its own vision of equity to itself, to determine its own target, but does not apply it directly to assess the emission of another country. So should countries agree to preserve the current uncoordinated situation of the Paris Agreement, where each country determines its own nationally determined contribution? This is a way forward that reflects that current bottom-up nationally determined contributions and makes it consistent, or offers a numerical way to make it consistent with the global goal.
I'd like to ask everyone to join me in thanking Jan for a very comprehensive. One final point, that's the first graph I've seen that shows that Australia is not the worst developed country in terms of its ambition.
Nice.
It might lie, it has a specific perspective, and Jan's just told us all about that. Thank you.
Thanks. Thanks for coming.
You're so close to being there. Yeah, that's really
Just out
good.
of interest, what are the factors that contribute to